Hello, this is a short follow-up video to the high stability oscillator option that I built for the my HP 53131A counter. I had a whole bunch of requests for people that were interested in doing the same thing, or at least getting the PCB. So I got some made, and I was just going to, this is a quick update video just to cover the PCB and also cover the types of OCXO oscillators that the PCB footprint supports. I'd spent a little bit of time just finding the ones that were easily available or quite highly available on eBay, and I laid out the footprints on the board just to cover some of those oscillators. So I'm just going to go through them now very quickly. So the first two footprints, or the first footprint is for this ISO temp. Let's see how we can. Yeah, that's focused. I'm looking to my right here because I've got a monitor over here, so I can check the focus easily. So yeah, so this is a ISO temp OCXO 131-100. This is a 5 volt oscillator, so it requires 5 volts. This is exactly the same, except for this is a 12 volt version, and you've got to be aware that there are two versions of this. There they are, but they're the same footprint and the same pin out, the same connections. The 5 volt one seems to be thicker than the 12 volt one here, but as I say, they work both the same. What I've done on the board to deal with that particular one here, you'll see right on the board here, there's a little jumper that you can set the power that runs that oscillator type from 5 volts to 12 volts just by linking out one side or the other. So that's those. The next one it takes is this datum 105243-0002, and sorry, just before I come back, so you can see, let's get this oscillator. It's got a bit of solder on it there, so I'll need to clean that one up. Yeah, so that's the board. You can see that footprint goes in there and fits onto the board quite nicely. So that's that footprint. The next one is this datum, as we talked about. This has got 7 pins on the back, and this is quite unique in as much as it's got separate power for its oven and its oscillator. And this is specified to run at 24 volts, but actually it works at 12 volts. I've done a fair bit of testing with this and verified that it draws enough current, the oven draws enough current to warm it up. It warms up in a reasonable time, the current drops off even at 12 volts, and the oscillator runs and you get a good solid output on that. And that fits on there like that. So you can see that's that option. That's that one. The next one that fits is the same oscillator that I'd used in my counter previously, which is an Oscilloquartz OCXO 8663, 5 connections, and that one sits in the board like that. So okay, so these are the options. Now, unfortunately, as ever with these PCBs, often I'd actually added a footprint for these type Trimble 34310-Ts or T2s, and these work quite well as well, and they're quite easily available. Unfortunately, when I laid out the board, I made assumptions about the footprint because I didn't have any. I didn't have one in my hand, and although electrically it's meant to fit, it would work. There is the outline footprint is there for it. It doesn't actually fit. It's about 1 millimeter out. So unfortunately, these boards, if you have one of these and want to use it with these boards really aren't that good. You possibly could drill, and I wouldn't bother. It's just not the right thing to do. So unfortunately, it only supports those 4. I'll document each one of these on the associated blog page, and you'll be able to get to the blog page from the link just down below. So what I'm going to do now is I'm going to take this board and populate this with some components, and then build each one of those OCXOs and just verify and test it, and then show you the results of those. Okay, so here's the board all built up. I've put all the components on there. I've left out specifically the links for the OCXO, and also this link over here, and we'll cover each one of those as I cover each OCXO configured. You'll also notice across here, up the top here, there's actually three places for 0 ohm resistors, which mark the which set the type of voltage control range that the ADC supports. Sorry, the DAC supports, this DAC chip here, and that's plus or minus 5 volts. 0 to 10 volts and 0 to 5 volts, and obviously each different OCXO has different requirements, and again I'll document those as we build each one of these. So let's go and build it. I'll put each one of these together, and I'll get set up so I've got a counter here to test these on, and we'll have a look at each one in turn. Okay, so first up is this IsoTemp OCXO. Just got it plugged in, hanging outside the counter here. I've got the same setup on the scope, so I've got the 10 megahertz reference here, and then I've got the output of the counter also in the scope, so I can see the thing there. So this has been running for about 10 minutes. This OCXO seems to have stabilised at around about that frequency, so it's showing 0.538, 37, 38. So we can just calibrate that now, hopefully. So just as a reminder, press and hold the offset button here, and it should say Cal unsecure. Press again 6 times to the right, press enter. It's a bit silly, you have to wait for this message, but there we go. Alright, so I'll just let that calibrate, and then I'll turn the camera back on when it's done. Okay, I actually, this one failed its calibration. I had to mess around with it a little bit, and in the end I had to move it to use a different mode, to use the plus or minus 5 volt mode. Not that it sits at a negative voltage at all, it actually sits at about 2 volts, but for some reason the firmware in here doesn't calibrate it properly. But if I moved it to there, I'm going to do the oscilloquartz ones. Okay, so there it is working. I'm just going to let that warm up now. I think this one takes about 15 minutes because this is what I used in my own counter. Let's see how that one goes. I'll come back on camera when it's warm. Okay, so that's the oscilloquartz oscillator running. It's warmed up now. It's been warming up for about 15 minutes. That's probably good enough just to test it. So again, run this through its calibration cycle. I'll let that calibrate, and I'll come back on camera once it's done, no doubt. Now this OCXO is rated at 0 to 10 volts, and watching it try and calibrate, it was actually failing the calibration on this oscillator, and measuring the frequency control voltage, what I found was the calibration routine would only pull it down to 5 volts. It wouldn't go any lower than 5 volts. So this actually, it couldn't, and therefore it was failing the calibration each time. So what I've done is I just to kind of prove a point, I moved over to the 0 to 5 volt range, just to see if it would pull it into range, which of course it has done. It's calibrated it now, and you can see it's done a pretty good job at calibrating. Now the way this calibration routine was working, it got it broadly there, a little bit low, and then it just incrementally, almost bit by bit probably, it just incremented, and then it counted, then it incremented, and it eventually crept its way up until it passed the calibration. So it was quite a long, lengthy calibration cycle. Okay, so that's the datum, and its calibration has passed also. So that's let's just run that. Okay, so that's the datum variant. Okay, that's it. They're all the boards are working. I had to tweak around a little bit with the voltage ranges from the DAC, because obviously the centers of those oscillators were not quite in the right place in all cases, but definitely tunable each time, and as you saw, all 3 calibrated nicely in the end. So that's it. The boards are done and tested as far as I'm concerned. There's a couple of other points I wanted to cover. Someone was asking me, would I provide a kit of parts, and I'm not really geared up to do that, so that's not it's not something I'm going to try and do. However, what I will do, I am going to get some built. I'm going to build some and make those available ready-made with all the mounting brackets and the cables and everything else that's needed. for those that are interested that don't actually want to go and source all the parts and build it themselves. Other than that, obviously the boards are available, so if you want to have a look on the blog page that goes with this video, you can access, if you're watching in YouTube and not watching from my blog, but if you're watching YouTube, the link to the blog page is just down below here. Just click on there and have a look at the bottom of the page, and you can order the boards there. I've tried to simplify the pricing and flatten it, so it's just easy for me to deal with. Otherwise, postage for people that were. I had quite a lot of requests for these boards, and they were coming from all over the world, so I didn't want to have an overly complicated shipping problem with the boards, which is why I've done it like that. Anyway, hope you found that useful. If you like the video, please give it a thumbs up, and I'll catch you next time.